Okay, so I'm doing test 3 corrections. So I missed all these multiple choices for various bad reasons. The first one, I started out doing it the right way, comparing the two, and I did it mathematically right in my head, but then for some reason I thought that they would end up being the same, and I did it back over here and solved it all out and found out that it would end up being 2r instead of just being r, which I originally had put out solving it mathematically, so E. The second one, I did a very similar thing where I was using, I just used the wrong equation this time. And if we're taking r to be an infinite number, using the v equals kq over r equation, r goes to infinity, which would make that 0. So the potential at the center of the sphere is going to be the same at the surface for that one. All right, and number 3. For the RC circuit one, I just wasn't thinking correctly about batteries. Once it's all fully charged, there's not going to be any current inside the thing, right? So I put D and it should have been C. Once it gets fully charged, there's not going to be any current. I knew better. So number 4, I was doing this one right as well. Like, I had the initial setup correct, but I wasn't thinking about the force being opposite the electric field, and so if the force is going the same direction of the electric field, there's got to be some external work going on to make that happen. So if that happens, there's going to be some potential energy increase. Oh no, the potential energy would be, yeah, the potential energy is going to be increasing, but there'd be a lower potential. Yeah, if it's moving in the same direction, some external work is required. That creates a positive potential energy. All right, and number 5, another thing I just slipped up. I wasn't thinking about it correctly. I had it as A on my test instead of the correct answer, C. And I think that was just a blunder in my head. P, obviously, well, P and Q and R are all going to get a same potential, but P is going to have a greater resistance because it's not combined with another bulb. And the current in S and T are also going to be the same, but in parallel, or in series, I should say. Sorry, and so the correct answer would have been C. So number 6, I made a dumb mistake where I had it as 27,500 and then I put it as 2,800. I just forgot a 0. So that was just a little dumb mathematical error on my part. On number 7, I set it up the right way. I was doing my integration from the beginning the right way, but instead of doing it from 2.3 to 4.2, I should have done it from 0 to 2.3, which I did over here. And then from 2.3 to 4.2, and so I put those numbers in the right way the second time, and I think I got the right answer with the voltage of A being greater than the voltage of B, and the correct answers for each of them being, our V1 was going to be negative 1.22 volts, and V2 is going to be negative 3.73 volts. All right, number 8. I had the first part of it right, the 0.33A. I got that right on this side, 0.33A. And the second one, I just made another mathematical error on it, and I didn't have it set up the right way. I should be looking at 8 right there. And so I just did a mathematical error and it messed me up. So the I1 would end up being 0.68 amps to the left. 9, a similar type of thing. I had my initial setup correct, but when I did it over here, I set up my Kirchhoff's law. I got my left loop and I got my right loop set up. Used those to combine together to cancel out my I2R1 with a negative I2R1 from the second equation, and then after those are canceled out, we're just left with our two unknowns. So our and our I1 and our I3, I think, is what it was. Yeah. And then, yeah, just doing some elimination right here. I ended up with my I1 being 28 over 500, which gives me my I1 equal 0.056 amps to the left. Okay, so 10. I set this one up the right way. I don't know if my calculator, I'm using the super basic calculator, and when I do this mathematical equation, it comes out with 0.000002 or whatever to 2 times 10 to the negative 9 nanofarads. And over here I had it at 1.6 because I went through my calculator to try to get a more fine answer than just the 2. And I don't know if I did that wrong or what, but I did it the same way. Over here, just got 2 nanofarads. So 11, another dumb mistake. I just forgot the negative in the denominator. So I ended up with the same number, 77 volts, but over here just with the negative. All right, and number 12 is where I made my big blunder. I thought that once I got I started it out wrong in the first place because I was putting it in parallel and not series. And so when I put it correctly in series, I get my initial C as 38.2 microfarads. Then I put it in my Q equals CV, and I get my initial number right here, which I'm going to use to find all the rest of my energy numbers for C1 through C4, right? So I first do C1, getting my C1 over C1 plus C2 times my Q, put that out, end up with this. Then I use that to get my potential energy over here with the Q squared over 2 times C1, and I get that. And so using that same method, I went through and found my energy levels for C1 through C4 as 0.0126 for 1, 6.2 times 10 to the negative 3 for the second, and 22 times 10 to the negative 3 for the third, and 6.9 times 10 to the negative 3 for the fourth. And that's it. I assumed that it was much shorter than that, and I thought that C1 through C4 would be the same number, but definitely was not. And that's my test corrections.